Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Younger Dryas Platinum Anomaly. 12,900 years ago, the average global temperature dropped significantly at the onset of the Younger Dryas cooling event. The cold event lasted for approximately 1,300 years. Then, the temperature rose as quickly as it had dropped, restoring the general warming trend that had preceded the sudden drop in temperature. The onset of the cooling event is associated with a large increase in the concentration of platinum at the Younger Dryas Boundary. Platinum is a precious silvery white metal used in jewelry, electrical contacts, laboratory equipment, and industrial catalysts. This image shows a US 1-ounce platinum coin with a value of about $900 rather than the $100 embossed on its face. This view of the periodic table of the elements highlights the position of iron in the iron-loving siderophile elements. The word siderophile is derived from the Greek sideron for iron and philos for loving. The siderophile elements include ruthenium, rhodium, palladium, rhenium, osmium, iridium, platinum, and gold. The chemical symbol for iron, Fe, is derived from ferrum, which is the Latin word for iron. Iridium and platinum are of particular importance because they are rare in the Earth's surface, but they are more common in comets and asteroids. The iridium story. In 1980, a team led by Luis Alvarez and his son, Walter Alvarez, published the discovery that sedimentary layers at the Cretaceous-Tertiary, or KT boundary, which is now called the Cretaceous-Paleogene boundary, contain a concentration of iridium hundreds of times greater than normal. Iridium is very rare in the Earth's crust because it has a great affinity for iron, and most of it sank into the Earth's core while the Earth was still molten. The image on the left shows Luis and Walter Alvarez leaning on a section of the KT boundary that has been tilted by tectonic forces. The Alvarez paper proposed that an asteroid struck the Earth at the time of the Cretaceous-Paleogene boundary 65 million years ago and caused the extinction of the dinosaurs. The paper was the subject of great debate and criticism because no impact crater was known, but 11 years later, in 1991, Alan Hildebrand tracked down the location of the crater to the Yucatan Peninsula in Mexico by investigating the thickness of debris that covered the layer of iridium at various locations around the world. The crater, called Chicxulub, is approximately 150 kilometers in diameter, and it was formed by an asteroid or comet with a diameter of about 10 kilometers. In 2007, the Younger Dryas impact hypothesis proposed that an extraterrestrial impact was responsible for the extinction of the North American megafauna and the onset of the Younger Dryas cooling event. As in the Alvarez case, the site of the impact was not specified, and there was no crater. Stein Jacobsen, working with 3 co-authors, examined an ice core from Greenland. Jacobsen was expecting to put the Younger Dryas impact hypothesis to rest by showing that 12,800 years ago, the levels of siderophile elements did not spike, but instead he and his team found a peak in platinum. This graph shows the platinum concentration in parts per million on a logarithmic scale. The yellow insert shows the same data on a linear scale. The presentation of the platinum results at the 44th Lunar and Planetary Science Conference was followed by a publication in the Proceedings of the National Academy of Sciences proposing that a meteorite impact had caused a cataclysm that triggered the onset of the Younger Dryas cooling event. The researchers found that the metallic traces in the Greenland ice had low iridium content, but high platinum content. On this evidence, they concluded that the extraterrestrial source of platinum could have been an iron meteorite with low iridium content. Furthermore, they stated that an iron meteorite does not transfer enough energy in the atmosphere to result in an airburst as originally proposed by the Younger Dryas impact hypothesis. Mark Boslow, a physicist at Sandia National Laboratories, objected to the idea that the platinum anomaly was associated with the cataclysm and proposed that the platinum anomaly could be the result of a local, non-cataclysmic event such as the entry of the Cape York meteorite, which is an iron meteorite from western Greenland with a total recovered weight of 58.2 tons. The authors of the platinum paper replied to Boslow's criticism by saying that they had considered a localized deposition of platinum by the Cape York meteorite, but that this idea was abandoned because of the large difference in the platinum-iridium ratios between the Cape York iron and the platinum anomaly in the Greenland ice core. Additionally, the broad peak of the platinum anomaly indicated that the platinum in the atmosphere took a long time to settle, which was more consistent with a global rather than with a local event. In 2017, Christopher Moore and 12 co-authors performed elemental analysis on 11 widely separated archaeological sedimentary sequences. Their paper documents discovery of a distinct platinum anomaly spread widely across North America and dating to the Younger Dryas onset. The apparent synchronism of this widespread Younger Dryas Boundary platinum anomaly is consistent with Greenland ice sheet data that indicated atmospheric input of platinum-rich dust. These are graphs of 4 of the 11 sites studied by Moore. The boundary layer with the platinum spikes is associated with Clovis artifacts. The authors state that the platinum signatures at the Younger Dryas Boundary will be useful for inferring the relative stratigraphic position of early Paleo-Indian and post-Clovis occupations over large portions of North America, especially for sites lacking an ambiguous visual stratigraphy. Additional evidence of platinum at the Younger Dryas Boundary was found in 2019 and associated with the extinction of megafauna in South America. Metallic analysis of the site in Chile showed a spike in the concentration of platinum at the Younger Dryas Boundary. In addition, the ratios of other siderophile elements, such as palladium and gold, were significant. At this time, there is substantial evidence that one or more extraterrestrial impacts were responsible for the onset of the Younger Dryas cooling event and for the megafaunal extinctions in North America and South America. The platinum evidence is extensive and conclusive, but the location of the crater is elusive. Unlike the KT impact that killed the dinosaurs, the thickness of the sediment over the Younger Dryas Boundary does not offer a hint about the location of the extraterrestrial impact. There are several potential impact sites whose date is compatible with the Younger Dryas, like the Greenland crater under the Hiawatha Glacier. Also, Saginaw Bay, which is the convergence point of the Carolina Bays, and the Iturralde crater in Bolivia. Could one or more of these sites be responsible for the extinctions? Or are there other craters that have not been found yet? Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.